Welcome back, dear students. I am back with a new topic. I hope the last session has been helpful for you all. Let's go to the next topic. Let's see what is the new topic for today. The new topic for today is motion of a ball on an inclined plane. To understand it, let's perform an activity. Set up an inclined plane. Take a ball. Push it from the bottom of the inclined plane with the speed so that it moves up. Observe the speed and the motion of direction of the ball. Now, release the ball from the top of the inclined plane. Once again, observe the speed and the motion of direction of the ball. What you have observed, let's see. We observe that the speed of the ball increases gradually on the downward slope, but the direction of motion remains constant. Decreases gradually on the upward slope, but the direction of the motion remains constant. As you can see, what we have learned, let's see, we learned in this from this activity. In the both cases, we learned that the speed of object will change on the inclined plane, but the direction of motion of the object remain constant. I hope the last is clear. Now let's go to the next topic. Next is uniform circular motion. To understand it, again we have to perform an activity. Let's take an object which is tied to one end of a string. Try to rotate the string in horizontal direction as it makes a circle. Now draw its path of motion and velocity vectors at different position. As you can see, there is a diagram given. Assume that the speed of object is constant. Observe the velocity of an object. What we have observed? We will observe that the object will be moving in a circular path with constant speed, and the direction of velocity changes at every instant of time, as you can see in the graph. We learn from this activity that the direction of the velocity at any point is given by the tangent to the circle at that point during circular motion. As you can see, every time direction is changing. The direction of motion is therefore continuously changing, but the speed is constant. As we know that the direction of velocity is tangent to the path at a point of interest, so the velocity is not constant, because we know that velocity is a vector quantity. In this activity, we learned that the speed remains constant, the velocity of object changes continuously because magnitude of velocity is constant along the circular path. The only changes in velocity is due to the changes in direction of motion. As I have told you that velocity is a vector quantity. If direction change, the velocity change. I hope the last is clear. Now let's go to the next topic. Our next topic is motion of an object thrown into air. When we throw any object into the air, what should be the motion of that? To understand this, let's perform an activity. Just take a ball, throw it into the air while making some angle. This kind of throw is also known as projectile throw. Observe the speed and the motion of direction of the ball. Now we observe that what we observed, the speed of the ball decreases on upward slope and increases on the downward slope, and the direction of motion also changes continuously. As you can see. Now we learned that from this activity, the speed and the direction of motion both changes simultaneously, means together. Speed also changes and the direction also changes. From the last three activities, 1, 2, 3, 4, 5, we concluded that the changes in velocity take place in three ways, such as speed changes with direction remain constant, direction of motion changes with the speed remaining constant. And the last, both direction and speed changes simultaneously. The motion of an object is said to be in non-uniform motion when its velocity is changing, and the motion of object is said to be in uniform when its velocity is constant. I hope the activity is clear. Now the next topic is acceleration. Let's see what is acceleration. The velocity of an object can be changed by changing its speed or its direction of motion or both. In either case, the body is said to be in acceleration or said to be accelerated. Acceleration gives an idea how quickly velocity of bodies changes. We experience acceleration many times in our day-to-day activities. For example, let a train start from rest off at station A. When it starts moving, its velocity increases, and after a certain time interval, it attains a constant velocity. As next station approaches, its velocity gradually decreases and finally becomes zero at station B. This rate of change of velocity of an object is called acceleration. Here we can say that the term acceleration not only applies to increasing velocity but also to decreasing velocity. The decrease in speed as the body moves away from initial position is called deceleration, or you can say retardation, or you can say negative acceleration. As per the definition, the formula of acceleration of body is shown on the screen. As you can see, acceleration is equal to change in velocity upon time taken. If the velocity of an object changes from initial value, that is small u, to the final value, that is small v, in time small t, then the acceleration is a is equal to v minus u upon t. This kind of motion is known as accelerated motion, and the acceleration taken to be positive if it is in the direction of velocity, and it is taken to be negative when it is opposite to the direction of velocity. Acceleration is also a vector and is directed along the direction of change in velocity. Now the SI unit of acceleration is meter per second square. If an object travels in a straight line and its velocity increases or decreases by equal amount in equal intervals of time, then the acceleration of object is said to be uniform. The motion of a freely falling body is an example of uniformly accelerated motion. If you throw a ball from a building, it's an example of uniform accelerated motion. On the other hand, an object can be traveled with non-uniform acceleration if its velocity changes at a time. For example, if a bus traveling along a straight road increasing its speed by unequal amount in equal interval of time, then the bus is said to be moving with non-uniform acceleration. Suppose means sometime it's accelerated 20 km per second, sometime it's 10 km per second. Means the acceleration is changing but in equal interval of time. This is said to be in non-uniform motion. Got it? I hope the acceleration and the previous activity is understood by you all. We will back with a new topic. Thank you so much.